And I will look to share this, but that. I don't know. Is it sharing? Are you seeing this 4 levels of software testing?
Looks good.
Yep.
Okay, I can't tell looking at my screen because I still see you guys in the gallery, which is interesting. So yeah, the thought today was to just sort of go back to some folks might consider it basics, some folks might learn some things today. That's kind of the whole purpose. Software testing. How do you know you've done enough? What levels? Are there better ways to do it? So a little quick walkthrough of some high level concepts. I've been doing this for, I don't know, more than 4 decades. So at various levels, I can't say that I have always done rigorous testing, but I can probably give you some stories as to why you should, because when you don't, you often get bit. And I've seen, I find that research testing, the sort of testing we do, like testing models, testing data analysis results, is a little different than testing, a software application that is providing user services, or a user interface that somebody's trying to use, menus. So there's some of the comments in the write up here are more along the lines of functional testing for satisfying a user audience, and we don't always have that, but we'll touch on it. So the pyramid of testing, as they say. So you kind of start at the bottom, unit testing. And we'll hit them all as we go. So there's unit testing, and then one level up, integration testing, which is how do your units that you wrote, the functions you wrote, talk to each other, or the modules talk to each other. They all fit together into a system of some sort. It might be a small system, might only be 2 or 3 files that are working together, or it might be something very large like our integrated assessment model that has a pipeline with a dozen tools and a bunch of data conversions and some data analysis output, and then acceptance testing, which is how do you know you've satisfied your audience. So dropping down, unit testing, kind of just what it says. It's the kind of the lowest level. Unit testing can be as low as I'm going to test this one command to make sure that I understand how this command works. I find in the latest environments that we have that Jupyter Lab Notebook is a great way to just fiddle with a command, beat on it until it does what you want it to do. Are the options what I want? It's very interactive. So you can kind of unit test at the 1-line level if you want, or it's 4 or 5 lines in a notebook saying, if I built this array and I sorted it this way and then I indexed that way, is this the syntax I want, and do I get the result I want? So it's really good, really quick to spin up that sort of thing. And that's the lowest level of testing, and you kind of do it as you go to make sure you're happy with the 10 lines of code that you've written. Benefits, you're sure that you've got your corner cases tested, the first indexes being appropriately accessed, the last index you're doing the whole list, it's sorted properly. Examples of things you might run into, like if you're doing rolling averages on your data, it's like, okay, if you're doing a 30-day rolling average, well, what happens as you're walking through the first 30 days? What does that average look like when you've only got one data point? What's a 30-day average of one data point? Well, it's the data point. And as you go 2 days, 3 days, 10 days, 20 days, you might see that the rolling average is not what you thought it was going to be in those first 10 days, because by the time you get to day 30, that rolling average for the 30 days is finally fully formed. So those sorts of things you can poke at, look at, good things to do in unit testing so you don't have surprises. Challenges. You want to, if you've got it in your head, in your mind, or on the piece of paper, what the ultimate use of this function that you're writing is, you might expect that it's going to have ranges of data from here to there, no negative results, no gaps in the data. So if you have dependencies in your code that says, well, I don't tolerate not a numbers, but then you get to using the real world and you realize that, hey, there's, the not a number is pretty prevalent in the data we get. There's gaps all the time. So you might not catch that if you're not aware that your incoming data might be not exactly as clean as what you ran in your unit testing. That's kind of bridging over to integration testing, which we'll talk about in just a second. Testing coverage, it may be hard to do all those cases, all the corner cases, all the combinations. You kind of try to find your corners, your boundaries, your edges. One of the things, notice this little piece of Python here. You can bury a unit test right in your code, right in your normal code that runs all the time, if you see fit to do so, with these assert statements. So let me pop into, I have another 7 simple statements. So here's a little Python docs code. The assert statement basically just says, hey, just, at runtime, make sure that this is true so that, I have no zeros or I have no negative numbers. Or, if I'm getting ready to generate an average, I'm not going to divide by 0 somehow. You can protect yourself. If you don't do anything special, that code will run every time your executable runs. Every time your function runs, that little test will be asserted. If it is a somewhat costly test, depending on what you've written in your test, you might not want it to run that way. There are ways to turn your testing off. There is a Python -O flag, which basically turns this debug mode off and suppresses the output of assert statements. So you can do assert statements in your code and then run your code faster by throwing a tag on it later. So let's pop back into this, dropping to the next level of testing, integration testing.
Before you go on, just it's worth noting that the assert statement, if it's not true, it will stop your code from executing. Like it will raise an assertion.
It's an exception. Yes,
this exception.
You do that for if you must have no negative numbers, no negative wind speeds, or whatever you're assuming. If that is an assumption that breaks your algorithm, you can do an assert that says you might as well stop now because if we continue on, we're just going to have garbage.
Right. So because of that, most people write tests in an independent file, and then they'll have like a tests directory in their project, and they'll put all their tests in that test directory, and they'll have like a run tests.py that will run all the little sub tests for each unit. And then you can run that independently, see if any assertion errors pop up. And then your program won't necessarily crash every time you get an error.
Yeah.
You'll just run it on a regular basis and then be able to see those tests independently of the rest of your code. But
yep, as we go on here at the end, I'm going to talk a bit about automating tests versus manual tests, and what Pat just described is an excellent thing to do for test automation. Like every time you do a commit, you might want to go run these things to make sure that the changes you made has not violated any of these assertions that you had in your algorithms. So let's pop, any other questions in the audience for the folks that are listening before we move on?
I've heard that with the assert statement that you want to keep it in tests only, and that's like bad practice, at least in Python, to have an assert statement in your actual production code. Is there a reason behind that, or is that just a convention?
I think that's a convention.
Python's all about being Pythonic, and so it's definitely a convention. I always do that, but there's nothing stopping you from doing it. People won't expect it there, but like if you're writing a small little app and it's silly to like make a whole other thing for like your 2 tests, then I don't see why you just don't put it in there with it. But as projects grow, you'll want to it's just keeping things modular, right, Noah? Like we've talked about, in this before, like once projects grow to a big size, the more modular you can keep it, the better. And keeping your tests outside of your code just keeps it more modular, and then you don't have to worry about running it, when you're trying to do other things. So
yeah.
I say we've done similar sort of techniques A lot of times, if you're writing a function that's somebody else is going to call, you have a user base and they're going to like go do data getters. And we have assumptions about the format of what you're passing us for parameters. I mean, we do checking. We say, hey, if you think this you sent me wasn't a date time, I don't even know what to do. So we're just going to like punt. You can do that with an
Right.
assert.
Right. That's exactly the use case I was thinking of. I mean, there are ways around it. Like you don't have to use an assert statement. You could do a different.
You can do if
like a type
if my
checking,
parameter is not a date time, put out a message and quit.
Yeah.
Right. But then that's basically what assert does. Yeah.
Right. Scott, can you pull up your number, that other tab, the 7 with the assert?
The Python doc.
Yeah. There's one that starts
Good.
with 7.
Yeah. I'm just going to. I have a taskbar in the middle of my. Teams covered up my tab.
Just a little bit to the right, right there. If you click there, you're good.
Well, I have a taskbar there. I have a Teams.
Oh.
There, let me move my taskbar. There, now I can do that.
Yeah. So if you want to do stuff like that, Noah, do this. Do what it says the assert stands in for, and then make up your own.
Yeah, just do the if debug or if.
Yeah, make up your own exception. So oftentimes you'll like when you're doing an object, objects will have like their own set of exception errors set aside, like that they define that extend the base exception. And then when you call like a method and the parameter doesn't match, you'll just do a test like this. If not expression, you'll raise that like
raise an exception error, and then you
not
get
a
an
valid
handle or
parameter
someplace.
error, and it's a custom error that you've defined that you've extended from the base exception. That's kind of the standard practice. You don't want to use assert there because assert is kind of predefined for testing.
Okay.
Alexander has a question. His hand up.
No, I was just going to share in a previous project we used, I think it was like Flake 8 or something, and that just like automatically checks your code for formatting and other issues, and it will raise an issue with asserts. It doesn't like them, and I think it had something to do with if you ever run your code with like a Python optimization flag, and I'm not sure I've ever done that, but it'll ignore assert statements altogether.
Yeah, that's the dash.
Oh, okay.
Yeah, that's another great point. No, yeah, that's another great reason why not to use assert to check for parameter.
If you're relying
compliance.
on that and somebody runs your code with that flag turned on, it just cuts you off at the knees.
See, this is already very helpful. Thank you.
Well, we just wander around in the wilderness a little bit.
Okay.
Yeah.
We've kind of wandered off from testing to runtime exception checking, which, you can, both of them have their place and they both, give you some assurance that the quality of your output is there. There's different, there's no sense running code with garbage parameters. So how do you check for that too? It's like a runtime test, so to speak, production test. But it's not called that. It's not called testing usually. I'm going to pop back in here. So the next level.
Sorry, Chris.
Nope,
Alexander, what's the name of the code checker app that you were using?
I think that's what defines like the rules, but we were using the Poetry, which does installation and all of that.
Poetry, okay. I haven't heard of that one, but those tools are pretty slick. Like they're great for working in teams because they can really help you like homogenize your code. They'll test for like the right indents and good variable names and all that kind of stuff. So those tools are pretty neat. Poetry is one I'm not familiar with.
I guess I didn't. At an even higher level discussion of testing, there has folks have been seeking formal software verification forever. I mean, can you just set loose something else, some algorithm that can look at your code and tell you that it does the thing you want it to do? And the answer is we haven't really figured out how to do that yet in 100%. There are more and more tools that can do like this. the syntax assist or the common problems. It's like, I've noticed you've done this and you shouldn't use that, or you shouldn't, cast this variable. Things that can cause you to have subtle calculation differences. If you are throwing around ints and floats and you're casting them back and forth, and you can lose precision if you do things in the wrong sort of order. But so there are attempts to do like lint checkers that just look at your code and say, hey, am I doing anything that's like not appropriate for C code? What am I doing that's, bad coding practices? That's not a bad place to start. But eventually you're going to have to figure out whether the algorithm you wrote is giving you the result you thought, whether your Nash-Sutcliffe is really Nash-Sutcliffe or whether you've done something else. I'm gonna drop into integration testing just to move along here. And integration testing, there's a couple of levels of that even too. You can do integration testing between modules in your own code, but I think it's also valid to think of integration testing as, I'm going to use a library call that somebody else wrote, and I don't necessarily have access to any of that source code. I just have a document that says these are the ways I can call this code. And these are the things it will do, have parameters, different options. For your code to understand the care and feeding of this library that you're calling so that you get the result you want, that's a level of integration testing. You don't really, it's a black box to you what's going on inside that other module. But you might want to poke around and see, and that's integration testing that says, I'm going to vary the options and see if I like my result. If I turn smoothing on, if I'm doing something out of my work in the last month, if I'm running an interpolator on data, do I want to use nearest? Do I want to use linear? Do I want to use bicubic? There are things that what gives you the best result for your use of this module. And that can be an integration test, or you can do that during development to figure out what you like best. But that concept of saying, I don't really want to know about the details of what's inside the other box. I just want to know what it expects to receive and what I expect it to give back. And you're testing that level of integration so that if you're calling a module and you expect it to give you back a data set, but instead it gives you back a data array or vice versa, those are the sorts of things you want to catch. I mean, the module worked fine and it gave you back the data, but it's, in an array that's got an extra dimension in it or something. It's a 1, 5 by 9 or whatever. And that 1 comma is going to throw you for a loop if you don't know that it's got an extra dimension. So those are the sorts of things you look for in integration testing. Interesting here, the complexity does go up just because it's less and less obvious that I'm just testing a few lines of code. I'm testing, what could be thousands of lines of code inside that module, and what it decides to do, and what it does with, with data cases, what to do with missing values, what to do with, values outside the range it was expecting. Does it have parameter checking and just throw errors, or does it make assumptions? Are there optional parameters that, if you don't specify them, you get something that you didn't know you were getting? Those are the sorts of things you've got to dig into. So that goes into this, identify the integration points. What are the parts that you're making use of? What features of the thing you're calling? Basically, then you try to replicate the behavior during testing. If you don't have all the external, like if you don't have real data, you want to generate some fake data to stress the corners, on your, if you've got a range of data that you might expect, you want to make sure you test the entire range, that sort of thing. The automating of test execution, this is where we start getting into integration tests whenever possible, should be automated so that if I change my code and these other modules are just out there waiting, it would be great if my use of those modules is tested when I submit my commits or I make my changes. So if you can automate those, that can speed up your whole release process or your whole commit process. So let's drop. The next level is the system level testing, which is very high level. It goes from, in our case, if this was our integrated model that starts with some climate data and runs down through land use decisions and hydrology and limnology, and then does data analysis and generates plots. If you're going to run that whole workflow, you can't do, you typically can't do every corner, every combination, every possible, permutation every time. So you try to do system level testing once again to check those boundaries. That if when you're running your suite of scenarios, something is going to go, someone's going to stress your algorithm. This is the system testing. That might be for performance reasons. Did I scale up properly? I can do this with 1,000 farms, but what if I did it with 10,000 farms because that's what I need to do this algorithm on? What happens? My system test suddenly blew out as a n cubed order calculation, and it takes 72 days to run this calculation. And that's the sort of thing you said, well, that's not good. So that can
come back to the house.
there was some input there. Noah, your mic was the one that was flicking on that. Was that?
Oh, yeah. Sorry, that might have been some background noise.
Okay. All of these things need some documentation, and a lot of them make more sense if you're working in a team. I mean, if you are just the single developer of a very large suite of software, you're communicating with yourself, and you would hope you know what you said, but it doesn't hurt to write this stuff down and plan ahead. And eventually, when we get done with system level testing, and we think we're ready, we try to get just before we kind of set it loose on the world, acceptance level testing, and this is where I think probably a lot of us as research scientists and data analyzers maybe don't have a huge user community that are going to do acceptance testing, but it doesn't hurt to think of it as being, I'm going to hand this to Asim, and Asim's going to look at the graph and tell me whether he thinks the graph is the graph he wants. That's kind of acceptance testing. It's like you're not ready to generate all of the scenarios with all the output, but this is a sample output. This is what we're going to generate, and these are the parameters, and this is the color, mapping, and you show that to your audience and say, is this the output? Before I run 1,000 permutations and generate, a book of charts, is this what we should be doing? And that kind of fits into that last role of just, it's not that your code was wrong, it's just not satisfying your primary user's, desires. That's kind of where we get to acceptance testing. And this, and all of these are just general guidelines, like early stakeholder involvement. In this case, stakeholder would be perhaps your PI, or if you're working with a regulatory agency and you're going to be providing them some output that you specified you're going to provide in your grant proposal. It's like the sooner you can provide some sample of that and say, is this, does this meet the criteria for what we agreed we were going to provide? Doesn't hurt to do that earlier rather than waiting till the paper's written and trying to submit it. And that's kind of the hierarchy of testing. Questions on the sort of 4 levels before we pop quickly into automation versus manual?
So I feel like the difference between integration testing and system testing is the haziest of these for me. I think integration is like 2 things and system testing is more than 2 things.
Yeah. Pipelining. Yeah. So there's and it can be the scope. If I'm doing integration testing and it says I can run this module does 10 different things, I should probably run in all 10 of them, and make sure that I can do it in this mode, in that mode, with this option, with that option. In my system test, my particular system test might not exercise all of those. I might only be interested in 4 different runtime modes, or maybe I'm only going to use one interpolation method.
But then
it's a smaller set.
But then what you described just now feels a little like unit tests too. Like when you try to use the 10 different methods or 10 different ways to use something. I guess my point is, I feel like the first 3 especially feel like continuum, like versus
there's fuzzy,
hard,
there's
hard divisions between them.
There's not necessarily a hard division.
Yeah.
So I gave an opinion that when testing your code so that it works with all of the options or the options you're planning on using of somebody else's code, if that code is, if it was your other module, that's clearly integration testing. I'm going to check, my main program against my function that I wrote to make sure that I can talk to this function and get the thing back. Well, if that function was written by, NVIDIA and it's a CUDA library, the testing method doesn't change necessarily. You don't necessarily have all the insight into all the source code for that CUDA module, but you're still working with somebody else's black box code, and you want to make sure that if I call it, I get back what I expect.
Right.
It may not fail. It just may not give you the, it may give you the overfit model, or the assumption that focused on a single parameter only. That all the decisions were based on eye color instead of whatever you wanted.
Yeah.
So that's I see that as the sort of the integration testing. System level tests, that's where you there's a lot of things there, and some of that, like I said, is for scaling issues. It's like, okay, I ran my little postage stamp example, and all of my data range is in that little postage stamp example, so I'm pretty sure that I've got all the things done, but I haven't run it on 5,000 farms yet with a full watershed and 20 years worth of data. When you do that for one scenario and decide, well, how long is, do I run out of clock time and get booted off of the job pool? Do I exceed my data volume? Or if I were to continue down this path, would I exceed my data volume? I'm generating, a terabyte of data for every scenario, then this is probably not the way I want to go, and I should turn off some of those outputs. I see that as system tests.
Yeah.
So like, does it scale? Does it run well enough? Is there enough feedback that it's running? Those sort of things. It's like if it's a black hole, you something on the command line and it comes back 3 days from now. It's like you might want some method to monitor whether that system is working and progressing towards the solution. So that's what I see as system tests.
One of the things I feel like I always struggle with testing, especially as you move up the hierarchy from, unit testing to integration and system level testing, is I guess what they refer in the Relia software article as mocking techniques for external dependencies.
Yeah.
Because I feel like as you ascend that hierarchy of testing,
was that under integration?
Yeah, your external dependencies will probably get more complex, and they'll probably be usually there's greater variability in what those external dependencies might look like. So especially when they say utilize mocking techniques to replicate, are there? I guess I'm sort of thinking and wondering what are some of the best ways to sort of try to mock those internal dependencies, because it's, especially as you go up, I feel like it gets extremely difficult to for an individual to come up with every possible scenario, user input scenario, or
Mhm.
You know, it gets
I had not
exponentially.
heard the
Yeah.
mocking techniques phrase before, so that was a new one
Yeah.
for me.
No, I
Yeah.
dropped in chat some code that so we had a developer here, Morgan, what's Morgan's last name, Scott? Morgan Rogers.
Rogers.
And he did a bunch of testing on our IAM when we had that, and he used a lot of mocking in that. And so he took advantage of a Python package called unit test, and they have a .mock piece in there, and you can
Oh.
mock like any of the imports that you want that you don't necessarily want to worry about, but it'll just kind of like skip over it. So I just dropped in the chat a screenshot of a bit of code that he wrote that kind of like, okay, I don't really want to worry about all those imports. Like all those imports, I'm not testing. I just want you to glaze over them. And then we can
Gotcha.
call all of that later, and it will just kind of take it out of the code for you automatically. So that's a really neat little package that does some mocking for you. And I'm sure there's other ones that do a similar mocking, but it's whenever you have like an external call to something that you don't want to like worry about in your test, you just want to like have it kind of glaze over that and pretend that it executed it. That's where you can call that mocking. Use mocking to say basically don't
Just jump over it.
yeah,
Yeah.
jump over it, and then you can specify kind of if it's supposed to return a value, you can specify like what mocked value to return, even though it didn't actually do it, stuff like that.
Right.
I was
Okay,
going
yeah,
to
that seems
along
pretty
this-
helpful.
along the same lines, and I know we've done this some when architecting some software. A lot of times, I mean, you can't get it all done at the same time. You might want to do some integration testing of a particular flow before all of the underlying tools are really there. And one technique is to use, I'm just going to pop back over here to this, like the pass statement. You can code up this function you're going to call, whether it's a method on an object or whether it's an actual function, computational function. You can just put a pass. It just says, hey, when you get to this, just kind of come back out again, and you could return like say if that was going to be a float, it's like, well, I'm just going to return 4.5, whatever. I'm just going to give you back a number. If there was a range of what you think this thing is going to be, if it's temperatures or wind speeds or whatever it might be, cyanobacteria levels, just give back a representative value to see if the code, if it gets called when it was supposed to get called, and when it gives back a reasonable value, your code does something with that reasonable value. And then later on, you can get into that function and work on it and unit test it, and get rid of that pass part and put in the real work. So that's another way to sort of bootstrap integration testing.
Yeah, I call that manual mocking. I mean, that's exactly what mocking is.
That's exactly
Yeah.
what it is. To say it's along the same
I mean,
line.
without using a function, without using a package that calls it that.
Yeah,
You just-
I like the mocking in that the real code does exist. I just don't want to run it.
Yeah.
I'm not quite
Right.
ready to actually run that
Exactly.
thing.
That's exactly
But
it.
I'd like to, I know it's going to eventually give me back a 4, so let me just have it give me a 4 as in representative value, and then move on. And I'll feed that function better soon, and turn off the mocking. So
And when you do like this mocking, like I guess that really requires like a separate maybe like test directory in your project and some different test modules.
to turn on the
kinda, like,
mocking, turn
mimic-
off the mocking.
Yeah, or well, that's I guess what I'm wondering too is like when you're testing at the integration level, are you testing your actual code, or is that should that test still be like a separate test module that you've made specifically for testing? I guess, yeah, like what are you executing when you are trying to do these integration tests?
I would put all of them in that test folder if it was me.
Yeah,
And then you'll have some unit tests in there that test the individual modules. You have some integration tests that like use modules together. You also have system tests that say like, well, you test like a workflow. Like you could say test, you name like a Python file like test, like National Water Model download. That's going to
Mhm.
like do a bunch of different things along the way and use a bunch of different modules. So you can dump all that into your test directory and then decide when you want to run those tests. And you can,
Okay.
and if you're smart, you can have like a naming scheme that has like unit and all the unit test names and int and all the integration test names and sys and
Yeah.
all the system test names. If you want to make these hard boundaries, but sometimes the boundaries are, like we said, are fuzzy. So
Yeah.
sometimes they're
Right.
just, like test file download and save or something might be a name, but
Yeah.
name them smartly so when you
Okay.
go back, like what each thing is testing. And then usually there's like one master test file that like calls all those things so that you can just call one Python file and it'll run through all your tests sequentially. Like a main.
Mm-hmm.
Which brings us kind of nice segue. I'm going to pop over to the other article, which had this other article starts off with the same idea that there's this sort of pyramid of testing, but it does add at the bottom a discussion of manual versus automated, pros and cons. They both offer something, and there's room for both in a large project anyway. So that's the other. I guess once again, I stress that if you're working on code and you're trying to generate results to do a publication, and then you will never run this code again. Some of the rigor of these, like automating tests and doing a lot of a big test infrastructure, the cost of doing that might not warrant just having some tests that you run once and say, I'm happy with my code. Pat and Noah and I are sort of in the business of writing utilities that many people will use, hopefully for years to come. So we are a little more focused on how do we know that they're rock solid, and we I don't think we're doing a lot of automated testing right now. We did automated testing with some of our EPSCoR grants when we had half a dozen developers pushing modules for different levels of the system. We would do fit tests to make sure that somebody didn't go ahead and change something and change the order of the parameters in their call, and now nothing works anymore, or they deprecated something, they got rid of some function that they didn't know somebody else was still using, that sort of thing. So pros of manual testing, you get fast and accurate, quick. This is like if you're unit testing in Jupyter Notebook, 5 lines of code. It's right there. It's right in front of you, but you're basically not capturing any of that. You won't be able to run it again. It's not going to be running in your final code that might be in some Python module that you're going to send off to the VAC. You're not going to have the same Jupyter Notebook experience over there. But you can be sure that you've written the syntax. At the time you did the Jupyter testing, it was good. That's what you know. So it gives you an idea that you've crafted that line of code properly. And if I use that line of code in my larger construct, that it should not change unless you edit that line of code. Which is, well, if you had a suite of unit tests and you edited that line of code, you might catch that change that caused some downstream effect you didn't expect. So the cons: some tests are difficult to run manually. Less reliable testing methods conducted by you in sort of interactive environment. You're in a kernel and you're forcing a return code, and then seeing what happens to your code. It's like that's hard to repeat and have it be a repetitive or reliable filter for future changes. Alternatively, automated testing, like Pat was talking about, setting up a directory and setting up a main that runs all your tests. You can do these sorts of things in conjunction with Git, so that every time you do a push to your master repository, your main repository, the remote, it runs a suite of tests and tells you whether or not you've broken anything. That can be good if you've got a very complex system and you've got a lot of people putting changes into it. a lot of dependencies between those modules, having the ability to say that somebody did a push and updated the main repository, and it broke something underneath the covers that they didn't anticipate because they changed a data type, or they return a dictionary instead of a list, or something changed. So
Is that
there
like
are ways
something
to
you can do? Sorry, Scott. I
in
was
Git.
with the automate. Yeah, like the GitHub Actions. Is that like
Yep.
something you can set up? Oh, okay, that's cool.
Indeed, if you create this sort of runnable suite of tests, you can tell Git that every time a commit is made, run that. We've done that in the past. Pat architected some of it for our integrated assessment model. Didn't know you want to weigh in there, Pat, as to whether is it an onerous task? I know we didn't do it. We didn't always go back and update it.
It's not really that. I mean, you make that like kind of test main.py file, and you tell Git that's your test main.py file, and then you have to set up like a runner that has all the dependencies in it, like a
It's got to
container.
it's got to shell out and start a kernel and
Yeah.
run.
So you need a container that has your Python environment all set up in there, and you upload that container basically. Or you can have a little script that creates that container. Git will create it for you if you give it like a startup script for that container. And it'll just use it like a generic Ubuntu, and then you'll tell it what dependencies it needs. It'll install it first, and then it will clone your Git repository into that container. It will run your unit test, tell you whether any errors come out, and then it'll give you like a little green icon or a red icon if it doesn't work. And what's super slick is that whenever you do a pull request, it will run that test. So when you submit a pull request and I would go to it to approve it, I can see if it passes all the tests or not already. That's kind of super slick. So you know before you
I
accept
do
the pull
remember.
request whether it's functional or not. So
That is super slick.
it takes a bit of time, but like this is the core of CI/CD/DevOps, right? Continuous integration, continuous development, the DevOps process. So in fact, if you look at, I'm trying to find an example of this, but I can't up doing it quickly. But if you look at like Python modules and you're downloading Python libraries, a lot of times you go to like the main page and there'll be like a little list of stuff on the side with like green buttons and red buttons, and it'll tell you like if it's passing their acceptance tests that with that nightly build. And so you can see that a lot of the big open source projects run these tests every night after every build, and you can see how they're doing, and they have little buttons next to their, like down the left side of the screen that show you how the current dev build is doing on all of its tests. And so this is the thing that a lot of people use quite often. It's super slick to set up in Git. And yeah, it takes like about 10 minutes, well, maybe 5 minutes to set up the container, spin up, run the tests, come back. So it's not like free time, but it's totally worth it if you can wait 5 minutes to do a pull request, which usually you can.
I do recall back in our rack days that occasionally one of those tests would be broken, and it would be broken for some amount of time. So we had a lot of flagged commits, but it's like but we needed to update the test. It wasn't that the code was broken; it was the test was no longer valid.
This is the thing with testing that none of this stuff tells you. That is like it's additional technical debt, right? It's more stuff to maintain. So when you write the test,
go stale,
and then you decide you want to change your API or change like your programming structure, you have to change your tests to fit that change in the architecture. Otherwise, all your tests will fail. So now you have to change your code in 2 spots. And so it's not like free in terms of like, nice verification. You have to do like double the work. You have to make sure that like your original code works. And then whenever you change your original code, you have to make sure your test still makes sense.
But if you're using a development environment that helps you do refactoring, refactoring is like basically saying, I'm going to change the name of this variable everywhere. I'm going to change the name of this parameter everywhere. It should go find all of it, including the references to it in your tests.
Yeah, but that's just syntactical stuff. Like if you do anything that's like
I know
API difference or like, that's changing in 2 spots. And sometimes you're like, I just don't really want to bother fixing this test, and then things like Scott explained happen,
Yeah.
and a
Then you
test
just
is
say, oh,
broken for a
that's well,
while.
we expect a red button, a red, a red mark on that test because we know it's broken. The test is broken. The code's not necessarily broken. We're not sure the code is working, but we know that the test is not.
But at least it gives you like a to do, yeah, like a very
Yep.
visual, obviously, with a
Well,
big red button
you,
keeps showing up.
it's a lot of this stuff it can be risk assessment. It's like, okay, this didn't work. Is this a real error or something that doesn't represent the way I'm going to use my code anyway? There's 3 different operating modes, and I'm only using one of them in my system, and one of the ones I'm not using is broken right now. It's like, okay, I'm just going to make a note that I should go back and fix that, but for right now, nobody cares at the system level view. So, yeah.
Yeah, so but if the CI/CD/DevOps thing sounds interesting, like the automated testing, make sure you email me, because this is on my possible list of topics to discover in this seminar.
Yeah.
Once to kind of like set it up and show a quick little demo of it working in Git. And if that sounds like something that would be really cool to see, let me know and I can put that together. I found a couple good articles on it already. Just trying to figure out what people want to hear about. Testing is I find it kind of boring and like
The
laborious.
necessary evil.
But
I would not advocate not testing.
Yeah, it's super important.
Yeah.
And these automated tools make it less boring, make it a little more fun.
The downside of not doing a good job at this is, after you publish and, it's in the journal and somebody says, hey, by the way, this I tried to replicate your thing and it doesn't work that way. And you look at it and say, oh, you know what? I had a code bug. I didn't calculate that right. Or I used the wrong index, or that's not good. Then sometimes there's retractions or the amendments.
I think diving deeper into more like automated testing tools would be, I would find it super helpful, because the roadblock or the hurdle I always, in my mind anyway, with testing is what you mentioned earlier, Pat, where it kind of feels like you're just doubling your work to design a test. Yeah, but maybe it's worth it. It might be worth it if if it's a continuous project, and
exactly.
maybe those automated tools can really make it easier.
One of the other sort of code quality assurance tools we didn't mention, I don't think we've ever talked about, is code reviews or team programming. More than one set of eyes on the same piece of code is never a bad idea. Once again, it's overhead and it takes time and resource. Also recommended. There's some things are just hard to nail down. I recently had on a side project, I needed to know, I needed to know the maximum integer value for a 16-bit register, and it's 65,535, I think is what it is. And I dyslexied it, and I set a global variable to be 65,355, and said, just set that to the max. And man, things weren't working, and I couldn't figure it out for the longest time. And then I'd look at it and say, that's obviously the right number. And then it's finally, like weeks later, you figure out what was going on. That I just had fumbled, I just fumble fingered the setting of this value. And there's very little that's going to find that other than
that's the whole
looking
basis
at
of
it.
that's the whole basis of like the whole pull request process and all that, why those pull requests and workflows are so well used and so prevalent in programming in big projects, right? The idea that you have a pull request, there's a comment period. If you have a big team, oftentimes you'll like assign people to comment on it, and a minimum number of those people have to comment before the pull request can be accepted. Git has all of that built in, and it's all based on like that second pair of eyes idea.
Somebody should check on
developers.
this. Yeah. We didn't do a brain, it's like you made an assumption here that's not valid for everybody, so it's not good code. So anyway, that's what I wanted to bring to the table this week. Testing is good. Everybody should do some.
I have 2 thoughts on this, completely unrelated. The first one is a thought experiment. So imagine trying to do this testing on a big long script versus some code that was modularized.
Yeah.
It's just like a pure nightmare, right? Because all this stuff is based on the fact or the idea that and the assumption that you're going to write code in small little snippets. It can be unit tests, and then those unit tests go up to integration tests, and those go up to system tests. And if you have one big long script, all of a sudden you're missing the first two layers because you can't do the unit and you can't do the integration because it's just one big long script that's a system.
It is a
So-
system.
So I just think about like some of the code that we have, guys, that's like long, like
Getting longer.
AM type script. That
Yeah.
I mean, and some of it's not our fault, you know, like that we inherited the code and we just never modularized it. But writing unit tests on like big long scripts, so tests on any kind of tests on a big long script is just it's
Well,
just
I
painful.
would make a counterpoint to that. I don't think it's not that you can't do unit tests. It's just that unit tests now is also integration test. It is one level of testing.
It is.
I mean, you can write things that do the unit level exercising, but you're also going to be doing integration along the way because
Yeah,
it's
exactly.
you know, it only runs as a system.
Exactly. So just that's one food for thought. The other food for thought is on the acceptance testing. So I've done acceptance tests like years after software has gone out. And I think there is, as you look to like upgrade it and see how people are using it, I think there is like some merit to think of acceptance testing as like something you do for the lifetime of a software product, right? Because people get software and they use it, they kind of adapt to it. And you want to see how people are adapting to that software you choose or that software that you developed, whether they like are starting to like use it in dumb ways or do stupid things to like get around some design flaw. And a lot of those things you don't see right away, right? Because people are just like kind of exploring. But as people get into their habits and kind of find like their groove in using the software, you start to see like some habits that maybe the developer had never thought that people might use the software that way. And I think of when one of my first projects outside of grad school was doing acceptance testing on some home automation software that my company had written, and I did with the senior design team and our senior electrical engineers, computer engineers went to the homes of a bunch of people using our software, and we had a list of tests for them to perform, like turn on your music, switch your TV to this channel. And they went to a bunch of users and had this whole list of things to, have the users do when they saw what the users did and how many touches it took on the touch screen to do it. And then we came back and we worked with a professional consulting firm to fix, the tasks that took our home users.
Why is
like
it
15.
why is it 4 clicks to change the volume?
Yeah, why is it 15 taps to change to raise the volume in like, their bedroom, audio? It should be like something that's really quick. And it was a really great little project because we got to work with some cool consultants. Like the guys that designed the usability tests were former Apple Macintosh employees. And so they were like really great with like designing the test. And it was a really good little senior design project. But again, the software had been out there in the wild for like 4 years and we were still doing the acceptance testing on it.
Yep.
That's amazing. I wondered what people did for student design projects. Like we heavy ones in CEE, but I couldn't envision what they would be. I think that's amazing, actually.
Yeah, it was a really cool one. The kids loved it. Yeah. I loved it. It was super cool to work with these. And then we had a graphic design firm like redesign the whole interface. And it was great to work with them. I had these people that worked with like Nike and, like these huge companies, and they're doing a design of our little handheld touch panels,
That's amazing.
It was cool, yeah.
Huh.
And they bring and the expertise from each group was clearly obvious. Like you could see like where the programmer, like the design people couldn't implement that to save their soul, right? And the acceptance testers couldn't like design the software, in any world. But then the programmers came in and implemented all these ideas. And so it was really cool to see how all those puzzle pieces fit together with that expertise.
I didn't dwell on it very much, but in the 4 levels of testing doc, they did talk about who does it, and there were classes of people doing the testing.
Yeah,
developers are involved in all of it, but there are times you need to bring in other levels of expertise, and sometimes just somebody who doesn't know what the internals are to make sure that there are no, I'm going to use it the way it's always been used, so I'm not going to use it wrong. I mean, if you
Yeah.
wrote it, you know the way you expected it to run and how to call it. If you give it to somebody who says, here's the documentation, call this. If they can't figure it out, you probably got it wrong.
Yep. Well, cool.
Yeah.
So this is the last one for the year, team. We have AGU in 2 weeks. I think a lot of people are going to be there, so I'm not going to bother trying to do this then. And then it's holidays. So
Whoop,
we'll
whoop.
come up with a topic for early January and send it out. And we'll see you all then.
Woohoo!
All right.
And I'm not
Thanks for
teaching next
listening.
semester.
Oh, nice.
You're not teaching.
Yay. So enjoy your turkey, ham, tofurkey,
Lasagna.
There you
lasagna.
go.
Perfect.
There
I
you
love it.
Bye.
I'll see you
All right,
guys.
folks.
Thank you.
Bye,
Take care.
everyone.
Bye.
Don't play.